Hello friends, myself Swapnil Bansode. Today we are going to learn the very important topic from industrial automation system. What is control, how to control machines and their their automation part, their switches, hardware top hardware, etc. In this webinar we are going in this webinar we are going to learn fundamental of electrical hardware control using industrial automation system. It starts with the basic concept of control, where the electrical outputs are turned on or off using different input outputs, etc. And many other things like the session clearly explains why the controlling devices are required in industries and how control system improves safety, accuracy, and productivity. Different types of control systems such as on-off control, sequential control, feedback control, motion control, and logical control are discussed with the simple explanation and real-world example. The presentation also covers open loop and closed loop system, highlighting their differences, application, and limitation. A major focus is given to the electrical hardware component like switches, push buttons, selector switches, limit switches, relays, contactor, timer, motor starter, and sensors. Their construction, working principle, contact types, etc., and symbols, all the information about the electrical automation and their uses. So, first of all, we are going to learn what is control. The output on and off by the help of input devices that is called the control. Control is a set of technologies that achieves desired patterns of variation of operational parameters and sequences for machines and systems by providing the input signal. Example on control. One example of a simple control circuit is the circuit that turns a light on and off. In this circuit, the control component is often a single pole switch. मतलब कि जब हम जस्ट लाइक सीधा एकदम पर देखेंगे तो अगर स्विच ऑन किया तो लाइट चालू होगी और लाइट ऑफ अगर स्विच ऑफ किया तो लाइट ऑफ. Need of controlling devices, types of control. Normally in industry we are using different types of control: on off control, sequential control, feedback control, motion control, and logical control. First of all, we will on off control. It is the simplest method of control where desired output may be on or depending upon the input signal stage whether it will allow or block the signals. Sequential control. A control system in which the individual steps are proceed in the predetermined order progression from one sequence step to the next being dependent on defined condition being satisfied. Such a system may be the time dependent in which the steps transition conditions are function of time only on external event dependent where the conditions are function of input signal only, or combination of this, and perhaps more complex condition. Next is feedback control. A control system which monitors its effect on the system, is controlling and modifying its output accordingly. Third one is motion control. It is a subfield of automation in which the position and or velocity of machines are controlled using some types of devices such as hydraulic motion, pneumatic motion, or linear actuator or an sys. Next one is logical control. In control, the output device is operated by the help of logical instruction programming languages, microprocessor, microcontroller, and PLC. यहाँ पे हम गेट्स यूज करते हैं जो हमारे बेसिक गेट्स या यूनिवर्सल गेट जो होते हैं वो गेट्स यूज करके हम सर्किट जो है कंट्रोल कर सकते हैं. उसके बाद है फैक्टर. ऑल द कंट्रोल सिस्टम डिपेंडिंग अपॉन टू लूप्स, open loop system and closed loop system. Open loop system have no access to the real time data about the performance of the system and therefore no immediate corrective actions can be taken in case of the system disturbance. The system is normally applied only to the case where the output is almost constant and predictable. Therefore, an open loop system is unlikely to be used to control the machine. Closed loop system. In case of closed loop system, feedback devices closely monitor the output and any disturbance will be corrected in the first instance. Therefore, high system accuracy is achievable. This system is more powerful than the open loop system and can be applied to case where the output is subjected to sequential. The types of signal. So, a signal is an electrical current or electromagnetic field used to convey data from one place to another. Signals are divided into two types, analog signal or digital signal. Analog signal is any type of continuous signal which represent has a physical measurement denoted as sine wave. Here the टाइम्स वेरिएंट फीचर्स इज प्रेजेंट। जैसे कि एनालॉग सिग्नल जो होता है कि वो जो है वो ड्रास्टिकली एनालॉग सिग्नल जो है वो एकदम से नीचे एकदम से हाई या लो नहीं होता। वो उसकी जो मोमेंटम होती है वो धीरे धीरे शिफ्ट होती है फ्रॉम 0 to 1 2 3 5 उसके बाद जो मैक्सिमम स्पीड पे आता है। फिर उसके बाद फिर से 0 होके उसके बाद लो मोमेंट पे ऐसे एनालॉग सिग्नल काम करता है। उसके बाद डिजिटल सिग्नल सीधा 0 to 1 होता है मतलब ऑन या ऑफ। डिजिटल सिग्नल इज एनी टाइप ऑफ डिस्क्रीट सिग्नल which represent has a physical measurement denoted as a square wave. Here the time value is constant. History of process control, manual control, hardware logic control, electronic control using logic gates, programmable logic control, manual control. All the action related to process control and automation is taken by operator. Major drawbacks here is the human error which affect on quality of final product. The, the manual control has its own limitation on mass production, so it cannot provide quality goods with an affordable price. The safety or efficient use of raw materials are totally depending on accuracy of human action. Example of manual control. Manual control circuits are use components that require human interaction in order to operate. Example of manual control circuits are component that require human interaction in order to operate। मतलब कि जो स्विच जो होता है वो ऑन और ऑफ करने के लिए जो होता है वो ह्यूमन इंटरेक्शन की जरूरत पड़ती है। हार्डवेयर लॉजिकल टर्म। This was considered to be the first step toward automation. Here, contactor and relay together with the timer and counter were used in achieving the desired level of automation. This method served the task for many years, but still it had certain limitations. Bulky and complex wiring involves a lot of rewiring to implement changes in control circuit. Third one is the work is started only when the task is fully defined, so it takes a longer time. एग्जाम्पल में देखा जाए तो ये है एक एग्जाम्पल जिसमें कॉम्प्लेक्स वायरिंग जो होती है कॉन्टैक्टर रिलेज और इसका यूज करके फिर उसके बाद इलेक्ट्रॉनिक कंट्रोल यूजिंग लॉजिक गेट्स। हियर द digital logic gate replaced the relays and contactors in the control circuit. The mechanical timers were replaced by electronic timers. So the benefits are the reduced space, energy saving, less maintenance, better reliability. So this method of automation was popular for quite some time. Programmable logic control. With the development of microprocessors, the process of control and automation was totally changed. Instead of doing the control in physically wiring using the PLC, it is done by a program. Due to the use of program, it is called as programmable logic controller. Nowadays, these types of controllers are rapidly used in control the process. Example of automated plants is the, the first one is the truck position, start or stop. These are the some example of fill the bottle machines. The bottle fill up the these are the few example of automated plant. Controlling devices input. Basically in industry different method controls are there such as mechanical control, electromechanical control, electronic control, hydraulics and pneumatic control. What is switch? A switch is a type of device that can break and make controlling circuit, interrupting the signal or diverting it from the one point to another. Signification of different switching devices. Steps to follow to find out the switching devices. Contact parts of switch, actuation mechanism, state of switch. Contact parts of the switch. Every switch having incoming path, pole and outgoing path. If the incoming path and outgoing path is connected with each other, then that is called NC, normally close contact. If the incoming path and outgoing path is connected, okay. If the incoming path and outgoing path is disconnected with each other, that is called normally open contact. The common contact is combination contact composed of a normally closed and normally open contact operated by the same devices with common electrical connected resulting in only three connection terminals. Actuation mechanism. The force that is required to activate a switch is called the actuation mechanism. According to digital input devices, different types of actuation applied: manual force, mechanical force, electrical force, or spring return force. The state of a switch. It is represent a switch having which state, whether the switch is on state or the off state, means on position or off position. Types of switches are toggle switch, push button switch, selector switch, limit switch, relays, contactor, timer, or sensor. The types of switches according to the actuation: manual force, toggle switch, push button switch, or selector switch. Mechanical force is limit switch. Electrical force is relay, contactor, timer, sensors. Spring return force, toggle switch, push button switch, selector switch, limit switch, relays, and contactor. Types of switch according to the construction: mechanical switch are toggle switch, push button switch, selector switch, limit switch. Electromechanical switch, relays, contactor, timer, sensor. Toggle switches are a switch that use a toggle joint with a spring to open or close an electrical circuit as an attached lever is pushed or shifted through a small pole. It is a different type. SPST, single pole single throw. SPDT, single pole double throw. DPST, double pole single throw. SPCO, single pole changeover center of. DPDT, double pole double throw. QPDT, quarter pole double throw. SPST is single pole single throw. SPDT, single pole double throw. That used in some motor switches like the DPST, double pole single throw. SPCO, single pole changeover or change off. DPDT, double pole double throw. Internal parts of toggle switches are the hand levers, body case, iron cover, wheel to pole, contact. The real part is the actuator, bushing, case, movable contact, common contact, stationary contact, common terminal, and output terminal. Push button switches, it is a one type of momentary switching devices. The deactivation is done using an internal screen. The, the maintained push button activates when the press, but remains activated when it is released. Then to deactivate it must be pressed a second time. For this reason, this type of switch is sometimes called a push button switch, push switch. The on or off switch on most desktop computers and laboratory oscillators are maintained push buttons. Push button switch. Types of push button depending upon contact. Contact type, NC contact type. Types of push button. Plain headed type, mushroom headed type. Types of push button depending upon operation: start process, stop process, common stop or emergency stop. Types of push buttons depending upon operation as per the color code: green start process, yellow inch process, red stop process. Lane, lane headed types, mushroom headed types, palm type, key to release, pull to release. Total view of push buttons: mounting plate, actuator, contactor block, modular contact block, modular holder, fastening nut, casing, plunger, lanes, nameplates. Switching terminology: momentary contact switch, a switch in which the shorting bar returns from its operating position to its normal or free position when the actuating force is removed. Brake force makes switch, BBMNC, a switch in which the moving contact breaks the connection with the first circuit before making contact with the second, also called non-shorting switch. Make before break switch, a switch in which the contact make connection with second circuit before the breaking contact, with the first also called shorting switch. Alternating action. Push-push switch. A switch in which the operable position is maintained after the first actuation, then descended with the second operation. Maintain contact switch. Pull to release, type push button Q to release. A switch in which the actuator remains in a position until it is actuated to another position where it is also remained until actuated. Joystick action switch, a lever switch which operates with momentary action in four directions. The symbol is momentary normally open, push button normally close. These are the symbols of momentary push button switch and maintain switches. The selector switch. The selector switch is also known as a rotary switch, which we can see in the regulator fans or the RPM modular selector. The symbols are these like three position, two position, non-bridging contacts, bridging contacts, limit switch. Limit switches are usually not operator accessible. Instead, they are activated by moving parts on the machine. They are usually mechanical switch. Examples are the refrigerator doors that turns on the light inside, door open and close. A limit switch is an electromechanical device that consists of an actuator mechanically linked to a set of contacts. When an object comes into contact with the actuator, the devices operate the contact to make or break an electrical connection. Limit switch is a switch operated by the motion of a machine part or presence of an object. They are used for controlling machinery as part of control system, as a safety interlock or to count objects passing a point. Limit switch application. Limit switch are used in a variety of applications and environment because of their rigidness, ease of installation, and reliability of operation. They can determine the presence or absence, passing positioning, and end of travel of an object. They were first used to define the limit of travel of an object. Hence the name limit switch. Example: refrigerator car door that turns on or off the light inside. Cam switches, door open and close. These are the some limit switch applications. Limit switch mechanism are common, NC process pulls the diaphragm towards limit switch. This is the internal of limit switch: stainless steel spring, silver alloy or gold crystal, common terminal, terminal, each terminal, phenolic case. These are the limit switch symbols. And next point is what is relay. The types of relay: EMR, solid state relay. Relay is an electrical operated switch which can control a circuit or different voltage or current. A switch that can be turned on and off by electricity instead by a person. Uses magnetic properties of material and the magnetic force due to electrical current. A relay is an electrical switch that opens and closes contact under control of another electrical circuit. The switch is operated by an electromagnet solenoid to open or close one of many sets of contact points. It was invented by Joseph Henry in 1835. A relay is able to control an output circuit of a higher power than the input circuit which is at a lower power. Next point is the what is the operation. When a current flows through the coil, the resulting magnetic field attracts an armature that is mechanically linked to a moving contact. The moving contact is supported by a spring which keeps the common contact normally connected to the LC. And when the coil get activated and a magnetic field is produced, the moving contact gets attracted, resulting a close path between yellow, yellow contact and common contact. The movement either makes or breaks a connection with the fixed contact. A relay looks like this is the image of the relays: lever, magnetic material, solenoid coil, spring, NC contact, contact, and common terminal. A relay looks like the pivot, armature, magnetic flux. These are the internal structure of the relays. So what is the inside a relay? Connections to coil, common contact, normally closed contact, and normally open contacts. Spring forces restore the lever when the coil is not energized. Magnetic force deflects the lever downward when the coil is energized. Inside the relay, spring forces when These are the disconnected and this is the connected. Wiring diagram of relay, bale, DC, relays, DC switch to switch. When the switch is closed, the bulb is low. Contacts of relay, normally open contacts on connect the circuit when the relay is activated. The circuit is disconnected when the relay is inactive. Normally closed contact. Disconnect the circuit when the relay is activated. The circuit is connected when the relay is inactive. Change over contact. Control two circuit. Now one normally open contact and one normally closed contact with a common terminal. Relays are used to control a high voltage circuit with a low voltage signal, to control a high current circuit with a low current signal, to detect and isolate faults on transmission and distribution lines by opening and closing circuit breakers. Solid state relay (SSR) is an electronic switching device that switches on or off when a small external voltage is applied across its control terminal. It serves the same function as an electromagnetic relay but has no moving part. So the lifespan is more than EMR, electromagnetic relay. For DC switching, for AC switching, optocoupler. So next is the what is contactor. These are the internal structure of the contact. This this is the main contactor and auxiliary contacts for add-on blocks. Definition: a contactor is an electrical device used for controlling power flow. It is activated by a control input which is at a lower voltage or current than that of control output. Application: contactors are used in applications ranging from the light switch to the most complex automated industrial equipment. It is used by electrical equipment that is frequently turned off and on, such as light, heaters, and motors. Contactors can be used as controllers in electrical control circuits or as an actuator in power circuits. The construction, it is composed of three different systems. The contact, this system is current carrying part of the contactor. This includes power contact, auxiliary contacts, and contacts. The electromagnet, this system provides the driving force to the close the contact. The enclosure, this system is the frame housing the contact and the electromagnet. Enclosures are made of insulating material like bakelite, nylon 6, and thermosetting plastic to protect and insulate the contact and to provide some measure of protection to personnel coming in contact. Open flame contactors may have a further enclosure to protect against dust, oil, explosion, hazard. The enclosure. This system is the frame housing the contacts and the electromagnet. Enclosures are made of insulating material like bakelite, nylon 6, and the thermosetting plastic to protect and insulating some measure of protection to personnel coming in contact. Open flame contactors may have a further enclosure to protect against the dust, oil, explosion, hazard, and weather. The constructions are the contact system, movable parts, spring, and foil. Characteristic contactors used for starting electrical motors are commonly fitted with the overload protection to prevent damage to their load. When an overload is detected, the contactor is removing power downstream from the contactor. Characteristics: some contactors are motor driven rather than relay driven, and high voltage contactors greater than the 1000 volts often have arc suppression system fitted, such as the vacuum or an inert gas surrounding the contact. Characteristics: Contactors are often used to provide central control of large lighting installations such as an office building or retail building. To reduce power consumption in the contactor coils, latching contactors are used with with two coils. One coil momentarily energized closes the power circuit contacts, the second opens the contact. A basic contact will have a coil input which may be driven by either an AC or DC supply, depending on the contactor, and and generally a minimum of two poles, double pole or three poles, triple pole neutral TPN. Contact points which are controlled when coil gets power supply. Operating principle. A contactor is a type of electrical relay. Unlike general purpose relays, contactors are designed to be directly connected to a high current load devices, not other control devices. Relays tend to be of much lower capacity and are usually designed for both normal closed and normally open applications. Devices switching more than 15 amperes or in the circuits rated more than a few kilowatts are usually called contactors. Apart from optional auxiliary low current contacts, a contactor only has normally open contacts fitted in general. When current passes through the electromagnet, a magnetic field is produced which attracts feathers object. In this case, the moving core of the contactor is attracted to the stationary core. Since there is an air gap initially, the electromagnet coils draws more current initially until the core meet and reduce the gap, increasing the inductive impedance of the circuit. For contactor energized with alternating current, a small part of the core is surrounded with a shading coil, which slightly delays the magnetic flux in the core. The effect is to average out the alternating pole of the magnetic field and so prevent the core from buzzing at twice the line frequency. What is the starter? Starter is devices that control the electrical power flow to equipment, usually as a motor. As the name implies, starters start motors. They can also stop them, reverse them, and protect them. Types of motor starter: dual starter, direct online starter, star delta starter, auto transformer starter, soft starter, VFD starter, resistance stator starter, slip ring motor starter. Dual starter. This is the simplest method to start the small induction motor up to 5 horsepower. In this method, the rated supply voltage is directly applied to the motor. Direct online starters are commonly used to start small water pumps, conveyor belts, fans, and compressors. So this is the control circuit of the and this is the power circuit with the contactor coil also. RDOL starter. RDOL starter stands for the reverse direct online starter. For three-phase motors which require bidirectional rotation, RDOL starters are used to change the phase sequence through power contactors to change the rotation direction of motor. These are the control circuit of the reverse direction motor, forward contactors and reverse contactors. Star delta starters. Star delta starters are used to reduce the starting current and starting torque of the three-phase induction motor. This method is used for the large size of induction motor more than 5 HP. Difference between star and delta starter. These are the connection of star and delta. RYB three-phase AC power supply. MCB overload relays, contactors and contactors, main contactor, star contactor, and delta contactor, and motor. Star connection or delta connection difference. In star connection, the starting or ending terminal of three coils are connected together to form neutral point. In delta connection, the end terminal of each coil connected to start the terminal of each coil. There is no neutral point. At star connection, the initial speed of the motor is low. It is used for minimize starting current. At delta connection, the speed of motor is high because each phase gets the total line voltage. The line current is equal to phase current. The line voltage is equal to phase voltage. The total power can be found out by the P equal to under root 3 into VL into IL into cos phi. The total power of delta connection is found by the next point is the timer. Timers are a critical part of the industrial automation and are necessary in sequential process where a machine follows a set operational sequence with the same some steps assigned a specific time stamp. Timers. In village ladder logic, the timer is called timing village because a contactor closure is associated with the timing function. Knowledge of the timing village is important because relay ladder logic implementation continues to be used in small control applications and where higher current levels must be switched. Definition. Timer is a device which will create some delay either in on process or in off process of an output. It is also known as the time delay village or timing village. Basically, it is of two types: on delay timer and off delay timer. On delay process. When we activate the input, output gets on after the given time delay, but when we deactivate the input, output gets off immediately. Off delay process. When we activate the input, output gets on immediately, but when we deactivate the input, output gets off after the given time delay. Time relay provides on delay and off delay timing. Timing context. Time delay relays contacts are specified as their normally contact or normally close contact. Time contact. With the additional requirement that the delay operators in the direction of closing or in the direction of opening. Time contact. The four basic types of the time delay relays contacts fall into two groups: on delay and off delay. On delay timing relays, the normally open and normally closed time contacts for on delay timing relays has special time. The normally opens are called normally open time close NOPC contact. The normally closed are called NCTO, normally closed time open contact. Normally open time close contact when the timing relay coil is energized, the time normally open contacts remain open until after the time delay value. After the time delay, the time contact change state and remains in on state as long as the coil is energized. When the coil is de-energized, the time contact immediately returns to their initial state. Normally open time close contact. Prashant sir, timing diagram. Normally close time open. When the relay when the relay coil is energized, the time normally close. Uh, Prashant sir now suddenly they call. మనకైతే the time contact change state and remain in the new state as long as the coil is energized. Immediately returns to their initial state. When the coil is de-energized, the time contact. The timing diagrams. Example delay. Off delay timing relays, the normally open and normally closed time contact for off delay timing relays also have special names. Off delay timing relays, the normally open are called normally open timing. The normally closed are called normally closed time close contacts. Normally open time open. When the relay coil is energized, the time contacts immediately close and remains in that new state as long as the coil is energized. When the coil is de-energized, the time contact remains in the change state until the set delay value is reached. The timers are normally open time open. At the end of the time, delay contact return to their initial state. Note that the delay starts after the power is removed from the coil. Normally open time open timing diagram. Example delay of 5 seconds. Normally open time open. At the end of the time delay, contacts return to their initial state. Contacts open. Normally close time close. When the relay coil is energized, The time NC contact immediately open and remain in the new state as long as the coil is energized. When the coil is de-energized, the time contact remains in the change state until the set time delay value is reached. Normally close or time close. At the end of the time delay time, contact return to their initial state. Note that the delay started after the power is removed from the coil. These are timers on delay and off delay. Normally open, time close. Normally close, time open. Wired on delay. Energy applied to power rail. Start push button is pressed. Coil is energized. Holding contact closed. Time contact stage closed. Lamp stage on. Wired on delay. Time count ends. Coil is still energized. Timer contact open. Lamp goes off. Timer contact remains open until the coil is de-energized. On delay timer. Power is applied to the rails. Start push button is pressed. Coil energized. Holding contacts closed. Timer contact stay open. Lamp stays off. Counter starts to the count. Third one is counter finish count. Coil stays energized. Time contact close. Lamp goes on. Timer contacts will open when relay coil is de-energized. Off delay. Power is applied to the rails. Coil is off. Contacts are closed. Lamp is on. Third, start push button is pressed. Timer contact open. Counters will start to count only when the coil is de-energized. Power is applied to the rails. Coil is off. Contacts are closed. Lamp is on. Start is pressed. Contact close. Lamp on. Counters only start when coils is de-energized. The timers. Schematic symbols for timing normally open, time close. The next point is the sensor. What is the sensor used in industrial automation? Electrical device capable of identifying changes within an automated process. Sometimes sensors is equal to switches. Use of the sensors. Sensor used in general are automation, automatic opening doors, conveyor stop, safety sensors on garage doors, glowing of lamps when the car door is open. Sensors used in manufacturing are the part position verification of tools, counting products, liquid level control, sensing of dielectrical materials, insulators. Personal safety system. Components of the sensor. The three major components: the sensing side, front end, the electrical side, back end. Sensors use an back end electrical voltage, AC or DC. Output types discrete, on or off. Analog signal selection based on the control system. The sensor housing material option: metal, stainless steel, aluminum, plastic, shape, tubular, block. The sensor housing material options: metal, stainless steel, aluminum, plastic. Types of sensor: inductive, optical, capacitive, magnetic, or mechanical. Sensor on the real world application: electrical control system, housing, environment. A discrete sensor is a switch. Sensing side: electronics, power wires, switches. Inductive sensors, current sensors. When voltage is applied, an electromagnetic field is generated and extend out of the face of the sensor. When metal enters the sensing zone, an eddy current is induced in the metal. The change in eddy current is detected on the sensor's output is energized. This is the sensor of inductive proximity sensor. Electromagnetic field, active circle, inductive coil, oscillator circuit, triggering circuit, output switching circuit. When the target absent, target present, and target absent. Inductive two basic sensing type: flash mount. Shorter range sensor can be buried in metal. No flash mount. Longer range sensor cannot be buried in metal. Directly factor. Different metals have different values of resistivity which limit the eddy currents and permeability which channel the magnetic field through the target. The type of metal being sensed will affect the sensing range. Inductive proximity sensors manufacturers derivate their sensor based on the different metal, with still being the reference. Drafting factor. If you want to sense a copper metal from 5 distance, so that what could be the sensor range we required? Sensing range is equal to 5 upon 0.30 is equal to 16.7. Basic sensor circuit sensors with relay output. Unlike a switch sensors required power to operate. Capacitive sensor. Capacitive proximity sensors will sense both the metallic and non-metallic object and also different types of liquid. It utilizes the electrical property. It utilizes the electrical property of capacitance and the change. It is of two type, dielectrical type or conductive type. In the dielectric type of capacitor sensor, there are two side-by-side capacitor clips in the sensor face. For this type of sensor, the external target acts as a dielectrical. As the target is moved closer to the sensor face, the change in dielectrical increases the capacitance of the internal capacitor, making the oscillator amplitude increase, which in turn on causes the sensor to the output on signal. Sensor electrostatic field, oscillator waveform, and metallic or non-metallic target. Conductive type. The conductive type of sensors operate similarly, however, there is only one capacitor plate in the sensor face. The target becomes the other plate, therefore, for this type of sensor, it is best if the target is an electrically conductive material. Conductive type capacitive proximity sensor requires that the material being sensed be an electrical conductor. These are the ideally suited for sensing metals and conductive liquid. They are ideal for liquid level sensor. Optical sensor. An optical proximity sensor includes a light source. It is capable of sensing any objects that are opaque regardless of a color or the reflectivity of the surface. These are generally available in one of the three types of light sources: red LED and infrared LED and incandescent LED and IR LED types of sensors generally have a light output that is pulsed at a high frequency. Optical proximity sensor is preferred for long-range sensing application. It is of the three types: through beam, diffusive, diffuse reflective, retroreflective. Through beam or dark one, imitator, receiver, output off and out on. IR emitter. This is the retroreflective in the object sees. Magnet sensors. Magnetic proximity sensors are non-contact proximity sensors. Non-contact proximity devices that are used to detect magnetic objects. Example: permanent magnet, color code of wires, sensor type 3 wires, 4 wires, 5 wires, red, brown, positive, black, negative, black output, white, in 3 wires, 4 wires, 5 wires. These are the PNP and NPN wires. in the contact senses, mechanical switches gets on. So when to use mechanical switches where physical contact is possible. Where physical contact is possible, where definitive position is required. So thank you so much. We will meet in our next session.